Well, welcome to Year 7 Physics. Just to show you, this is the layout of the course that we'll be doing this year. So the lessons are more or less go in order. We've got some regular assessments going on. It's going to be mainly practical activities. In most lessons will include a practical activity. But really this video here and this series of videos is just to help people who've missed lessons catch up if they've been absent for a lesson. So I'll go through and explain what we did in the lesson. And so you can at least keep your booklet up to date. So let's start off with the first lesson, forces. Objectives. I can identify and name numerous forces. I can identify contact and non-contact forces, and I can describe what is meant by a resultant force. So if you could date your work here up in the top, put the date in, and this what I normally start off with. I just throw it out to the class, what is a force. So if you want to pause the video there, just pause the video now and think to yourself, what is a force? And then when you've got some ideas ready, come back. Well, what is a force? Well, when I normally go around the class, the sort of ideas I'll get is forces make things that happen. They'll also name some common forces, like they might talk about air resistance or weight or gravity. Some might talk about push and pulls. And push and pulls, I always say, is quite a good one because that's sort of like a key stage 2 learning from primary school. That's how they introduce the idea of forces. We could try and get a little bit more specific in as we're preparing for GCSE, really, sort of we're doing it in key stage 3. So forces really could do a variety of things. They can make things speed up, they can make things slow down, they can change their shape. So we'll come and look at a little bit more detail about the sort of things they can do. To actually describe what is a force is actually quite a complicated thing. We can name them. So what we normally do is describe forces by how they behave. And in this lesson, we're going to look at some quite common names of forces. So for now, if you want to write anything down there, push and pull, you can just start, that would be fine for now. And we're going to develop on to those ideas from here. So what do we do in this lesson? Well, fundamentally, once I've got, because I think physics, you might hear me say this, or you should hear me say it quite a lot. Physics is a practical subject. It's a study of the physical world. So there are quite a lot of practicals in physics. So in this lesson, I generally just stop teaching and speaking and get the students to investigate. So unfortunately for you, you're just going to have to hear me go through the answer to some extent. So in this first carousel of activities, we've got two people pushing a north and a south magnet together. So hopefully a lot of you might realize, what do north and south do? They actually attract each other. The magnets are attracting because they're north. If you swap them around, the north and north would repel, and the south and south would repel. The force is stronger. It's what you can do. If you've got magnets around, go and grab them and have a go. The force is stronger when they're close together or far apart. Well, you've done this experiment. The force is strongest when they're close together. And the name of this force is the magnetic. It's magnetism. Oh, is it written there? I don't even know how to do that. I could just go there. Magnetism. There you go. That's the name of this force. What will happen if you turn one of the magnets around? Well, the key word is there. It would repel. Very good. Let's move on to the next carousel. Well, in this carousel, you would have got two blocks of wood. Two blocks. One a block of wood and one a block of ice. And when you try to push them along the desk, you find one of them goes easier. You've got a bit of ice and you want to go and try this at home, go ahead and do it. Pause the video. Okay, so the force of what stops the blocks moving across the desk? Well, this force that prevents movement happening is called friction. And friction works against motion. Okay, now which of those blocks have the least friction? Well, the one with the least friction is going to be, block of ice is going to be easier. Yeah, the block of ice is easier. And that's because on the surface of the ice makes it, and has a very smooth surface. And so it generally just moves easier across the desk. So friction is caused by really rough surfaces. And so the smoother the surface, the easier it is. Let's move on. So weigh the object. Now, if you were looking on here, if you can just see, this is actually, I can write it in, it's 2.5 newtons on that one. I mean, obviously, people would write down what they'd see. I'd give people different weights to measure there. And hopefully what this gets across to you is that, first of all, weight is measured in newtons. This is we'll come to another lesson, a Newton meter. And how much does your object weigh? In this one, in this picture, it's 2.5 newtons. Next one, the force of what is pulling it down? Well, I sometimes use force of gravity. Sometimes I'd allow weight there as well. Sometimes we can use weight and gravity. I mean, I think it's easier for me. Gravity causes weight. Gravity causes weight, but the force of gravity is pulling the object down is fine for this one. Now, go and get 2 pieces of paper and scrunch one of them up and drop them from a height. Pause the video. Which one dropped to the floor first? Well, it was the paper takes less time to fall or more when it's crumpled up. It takes less time to fall. It takes less time to fall when it is crumpled up. And that's because even though these 2 pieces of paper have the same weight, there is less air resistance acting upwards. There's less air resistance acting upwards when it's all scrunched up. Yeah, the air resistance is less when the paper. So you've got the weight pulling it down, but you've got air resistance as a force acting upwards. And the more you scrunch it up, the less surface area there is for the less surface there is for the air to act on. Okay, let's move on to here. This one is really with a piece of rough string and a piece of smooth string. If you've got anything like that at home, you can go ahead and do it now. And really, the plastic string, in this particular sense, this is a natural string made of natural fibers, and this is a plastic string. And what you'd find is the plastic string is easier. I mean, they're both relatively easy to tie the knot in. The plastic string is smoother surface, so there is less friction. Okay, so generally those two, you can imagine with this rough string here over here, that let's see, just colour that on, this rough one over here, that you're going to be resistance from all the little fibres pulling it together. I mean, obviously it depends on exactly which type of string that you're using, but the idea is that when it's smoother, again, we get less friction. Hopefully this one, if you've got any springs to hand, go and have a go at this experiment. The force from the spring, when we pull it apart, the further we pull the spring apart, yeah, the force from the spring gets, if it's stretched further, well, the further we pull it apart, the bigger the force, the bigger the force. The spring is actually not doing any, if you're pulling the spring apart, it's doing some pulling in together. It's not pushing, it's pulling your fingers in together, isn't it, if you want to fight them. Now, one more force I haven't mentioned yet, and I would normally do it with a demo, with a balloon, and I'd show, that's electrostatic force. Just if I rub a balloon on my head, and then I can actually get it normally to move my hair about. If you've got a balloon, you can have a go at doing that. Go and blow up a balloon, rub it on your head, and then see if you can stick it to the wall. And that is really just showing that there is another force that's called electrostatic force. Electrostatic force. I'll just write it down here. If you want to make a little note, electrostatic. And that's the force that you can see when you can make, even if you get a comb, and you want to get a plastic comb and you rub it through your hair a few times, and you could sort of attract your hair. You could even try and pick up small things like Rice Krispies or little bits of newspaper. Okay, so really that lesson was really about doing practical activities and seeing forces in action. One way to categorize forces is forces that need to be in contact with to have an effect, and forces that can have an effect without being in contact. So here we go. This is a comb that's picking up pieces of paper. Well, you don't actually need to have the comb. You try this at home. You don't actually have the comb once it's been charged up, actually touching the piece of paper, we're able to pick them up. That's non-contact force. That's static or electrostatic force. That's fine. Now this one is a water bottle bobbing along in the sea. It's the weight is pulling it down, but it's not sinking. And that's because it has what we call, the word I'd use here is up thrust. As up thrust, that's another force here. But clearly the bottle needs to be in the water to receive that up thrust. Here we go here. How do brakes work? Well, when you hit the brakes on here, that pad will go into there and it will slow the tyre down. Clearly the brakes only work when they're in contact with the tyre. So we're looking at contact force here. The name of that force is friction. This is clearly magnetism. As you've hopefully seen, if you've got magnets at home, magnetism you do not need to have the paper clips actually touching the magnet to have them have an effect on each other. There it is. It's a non-contact force. And here is my skydiver. The skydiver will eventually get to the ground. Skydiver. And the skydiver is being pulled down by the force of gravity. Or if you want to write in weight there, that would be fine. Okay, one more little sheet here. Look at the pictures below. Write the names of the forces next to the arrows. Have a go doing that now. Hit pause. See if you can name all of these. Then I will show you the answers. Okay, I'm going to show the answers now, so make sure you've had a go. Here we go. Why is the rubber ducky floating on the top of the water? It's because of upthrust. Why is the iron nail being pulled towards the magnet? Magnetism. Why is the apple falling? It's because of weight or gravity. We'll just use those interchangeably for now. When we pull a match, what's the force that is going to experience? It's going to be friction. This comb and the hair, that is electrostatic. And when the lady comes down the hill on the roller skates, she's going to experience air resistance or drag. If you can complete all of those activities in your booklet as well as possible, that would be fantastic, and you'll be ready for lesson 2.